Okay, heat transfer flows through surfaces. So let's look at this. Heat transfer flows through surfaces like, if you're an electrical engineer, it's like current. Okay, so if we look here and we have a wall and we have air on both sides of this wall, the heat transfer goes right through here, Q dot, right on through. Doesn't stop, doesn't change. It's a constant value through there. It kind of sees what it sees ahead of it. And we can talk about the air and the wall and the air as resistors, thermal resistances, but that current moves right through there. Okay, and so I know that I'm going to have in this wall, I'm only going to have conduction. Okay, conduction, and I might only have convection on in the air on the both sides. And so I am going to say that the conduction equals the convection. And that will help us solve a lot of problems because we know the Q dot conduction has to equal the Q dot convection going on here. Now you might be asking, Dr. Wanklund, what about radiation? Shouldn't there be radiation happening from between the wall and the surroundings? And that answer is yes. There may be radiation that happens as well, but often radiation in the problems that we're going to deal with is going to be a very small number. And so we are going to neglect radiation. You might ask, how do I know that I'm going to neglect radiation? Well, in our class, you will know to not worry about radiation if they didn't give you an epsilon. If you see epsilon in your problem statement, you're going to say, oh, they want me to consider radiation. If you don't see it, you'll probably write in your assumptions, I'm neglecting radiation. I have to give you the emissivity. I have to. That is a required thing. Okay. Now, some models do not say that radiation is negligible. Say it's going to be a thing that you have to deal with. In that case, what's going to happen is you're going to have conduction. Q dot conduction, and then it's going to split off here, and some of that's going to change to Q dot radiation, and over here is going to be Q dot convection. And so here you're going to say that Q dot conduction equals Q dot radiation plus Q dot convection. So it splits up, and that's what happens. All right, so that's what we have to understand. The problems that you're going to have on homework are going to take advantage of this fact of how the flow of heat goes through something, what goes in must come out. Okay, it just can't be. That's just how it is. What goes in goes out, and so we have to deal with it in this way. So pay attention to this fact when you're dealing with the homework, and you will be very successful. All right, that's all I have for you today. Until next time, have a good, safe, and healthy rest of your week.